All right, let's have a look at the Koranga Ako for today, which is applications of the properties of the discriminant function. So that leads us, of course, to using, or rather so doing, exercise 17.11. So we didn't get to this in class, so we're going to do it today. It really is a separate topic on its own in a way, because it requires you to take what you learned and take it to the next level, so to speak. All right, so how does this all play out? Um, First things first, the theory behind it. Let's say you're told an equation, you're given an equation of some sort with maybe an unknown of some sort. Obviously, x is an unknown, but here we've got a q here as well. It might be a p, a q, an r, an s. We use all sorts of variables for that. But we're told this has two real roots. So when we write the discriminant function, which is b squared minus 4ac, we know that it's going to be greater than 0. Now, if it said it's got one root, one real root, one repeated real root, then we would write equals 0. And if it said it has no real roots, then we would say less than 0. So that's how this plays out. So let's have a go at doing this now. Obviously, it's on the sheet here, and I'm going to have that there, but I'll just talk you through it so you can see my thinking as I do the calculation. So remember, it says it equals 0 here, but that's got nothing to do with the discriminant. That's the function, that's the equation that equals 0, not the discriminant. All right, so here it is again, and I'll write it out and tease it right out as I do it. So there's the equation. So it's, I'll restate it. So I've done it. 3x squared minus 4x plus q equals 0. Now, the discriminant is going to be based on what the value of a is, what the value of b is, and c is. So a is going to be the coefficient of x squared, which is 3. B is the coefficient of the x value, which is minus 4. And c is going to be q. So now I can put that into my discriminant function. So b squared minus 4ac. Now, I'm told it has two real roots. If it has two real roots, it's got to be greater than 0. So let's write this in. So b squared, that's going to be minus 4 all squared, minus 4 times a. Well, a is going to be 3 times c. Well, c is going to be q. And the whole thing is greater than 0. I'm trying to keep the greater thans under each other, not succeeding very well. All right. Oh, sorry, I've got b squared. That should be negative 4. I'm not concentrating. So this is a negative 4, and negative 4 squared is going to be 16. So I've got 16 minus 4 3s are 12 times q is q, and it's greater than 0. All right, well, I want to make q the subject. I want to find the value of q. So I'm going to subtract 16 from both sides. So I've got negative 12q is greater than negative 16. But I don't want to find that. I want to find the value of q. Now, whenever you multiply or divide an inequality by a negative, you change the direction, the orientation of the inequality. And I need this to be positive 12q equals positive 16. So I'm going to multiply this side by negative 1, multiply this side by negative 1, which of course will give me 12q. And on this side, I'm going to have a positive 16. But because I've multiplied by negative 1, I must change the orientation. So now I'm going to divide this by 12. I'm going to divide this by 12. And of course, I've got 12 divided by 12 leaves me with a q is less than, and we've got 16 on 12, which is the same as saying 4 on 3, or if you like, 1 1/3. Of course, I didn't have to multiply by negative 1. At this point here, I could have just gone negative, can you see that? Oh, you can, right. Negative 12q is greater than negative 16, and just divided both sides by negative 12. Divide by negative 12. And at the moment I did that, I would be wanting to turn that sign around. 12 divided by 12 is 1, leaving me with q. Q is less than, and I've got negative 16 on 12. Well, two negatives become a positive. So with 16 divided by 12, back, divide both into by 4, leaves positive 4 on 3. So the value of q only works in this equation, and that is yielding two real roots, as long as that value there is going to be less, I hate that. As long as the value of q is going to be less than 4/3.